fine. So we'll take classes and objects and chapter number 8, that is inheritance. So inshallah, these two topics inshallah we'll try to cover today in today's session, and we'll continue in the same link the lab session also. So we'll take lab with the theory sessions together inshallah today here. Okay, so in our last meeting we have done up to methods, right, or functions. So till now we have seen a sequential programming using C#, and we wrote some example programs. We did some lab sessions to cover that. So we are all aware about how we use different things for different tasks in C#. We all aware about variables, data types, operators, input output operations, conversions, data conversions. We are aware about the selections, the if statement, switch statements, the looping, while, for, do, while, and we have seen methods, and then we have seen arrays. Fine. So this is all the basics about the programming. In any programming language, you'll find these things what you have studied as the basic building blocks, or you can say the basics for any programming language to write programs. Today we are going to talk about classes and objects. This is purely with the object-oriented programming language. Any language which is object-oriented, in the sense there in this language we can have the classes, we can create objects of these classes, and we can use those objects to represent any real-world entity. For an example, if you take university, okay, in reality, what is university? That exists a place, right? Whether it is a physical place or a virtual place, but there exists a place which is called university, under which there exists some departments, right? Under which there exist there has been some functions going on, or some work going on inside it, such as, for example, there are classes, there are students, right? Students attending the classes, tutors taking, or professors taking the classes. There is called a registration, and students are making registrations. This is all the reality. If you want to represent the reality in programs, in terms of programs, what we call it as in softwares for the university, or to work of the to make the work of the university simple and easy, such as, for example, we have SIS, LMS, right? These software that makes the work easy for the university as well as for the students, the university staff. So we can represent them such as by using, which is a technique called object-oriented programming. So we consider here everything in the university as an object. For example, a student. A particular student is an object. A student has some data, for example, student ID, name, and XYZ. It is the one of the student data, and a student does some functions. Student makes registration, a student takes exam, a student submit assignments, right? A student get grades, a student can see the transcript. Number of functions a student does. So if you consider this, every student is an object, every object had its own data and performs some common functions, right? So what we can do in programming, especially in object-oriented programming, is that we can write a class called a student. There it specifies completely what is a student in general. In the sense, what does the student will have, what operations the student will do, right? All this is specified in the student class. Now from this student class, we can start creating the objects. From the student class, can start creating the objects. Right? From the student class, we can create the objects. So classes are something like, we can say, a factory, or we can say a place from where the objects are generated or objects are created. So once if I write a student class, right, where I specify what is a student, that means what are the data which is related to the student that I need to define, okay, with their types and so on, and what are the functions that the student will do that I need to define. Now when coming to the object, when I create an object from the student class, I create for any specific student. For example, student Ahmed. So Ahmed is a student, the object Ahmed is created, okay, and all its related data is being given to this object, and all the functions or the functions that the student does, Ahmed can do it. And how the Ahmed get all those functions is that it gets from the class. So a student class has basically what has the data, or we call it as a fields, and it has some functions, related functions. When we create any object of the class student, we create, for example, object Ahmed, then object Ahmed will have all this data you need to define for Ahmed, and Ahmed can call these functions using its data, right, to make the operations. Fine. So this is the concept of classes and objects in programming, which is in concept of object-oriented programming, which call it as an OOPS. We have studied, I think, Java. Java is also an object-oriented programming, right? So we'll see that how we can create the classes in C# and how we can create the objects in C#. Now, the objectives of this chapter is to describe classes and objects, create classes and objects, and explain constructor and destructor in C#, add constructor and destructor in C#, okay, in classes. So introduction, C# is a true object-oriented language, and therefore underlying structure of all C# program is classes. We have seen that whenever we write any program, we write it as a classes. Right? We have seen this here, for example, session 2 program. When we write it, we got a class, right? We got a class here, class program, and we have the main method. And what we do is that we write our program, whatever we want to execute, that in the main method. Fine, and we execute them. So what it is that we have classes. Every program is a class in C#. Okay, so a class is a template, declaration, or a blueprint that is used for classifying objects, or we can say for creating objects. Class can be used to create an object. It is a basic building block of object-oriented programming. That is an object. It encapsulates variable members, functions, structure, properties, and many more components. So a class has members, variables, functions, structure, properties, and other components. Classes create objects, and objects use methods to communicate between them. Thus, methods are defined. The object use method, these methods are these functions, which is defined inside a class. Classes provide a convenient approach for packing together a group of logically related data item functions that work on them. In C#, the data items are called fields and functions are called methods. It means a class will have fields and methods. So what are the fields? These are the data related to that class, data items that need to define inside the class, and methods are the functions that is written inside the class. Calling a specific method in an object is described as sending the object message. When we call any method by using an object, we say that the object sends a message. A class is essentially a description of how to construct an object that contains field and methods. In order to create a class, we use a keyword called class. That's what we see here. Let me just close this. That's what we see here, class program. So this is a class now here. It is a class. So class program. Okay, the basic definition for the class is the class, the name of the class. Then we have the variable declarations and method declarations. We can have an empty class without any declaration. This is an empty class without any body of the class. There is no variables declared inside the class. No methods are declared inside the class. This class is compiled, right? But it has nothing in it, right? You cannot do anything because it does not have anything in it. But still we can have a class. So for example, here I want to add a class empty. That's it. This class exists. It's okay, no problem. But does not have anything. You cannot do anything in this one, right? Because you don't have anything there. Fine. So now let us write a class called rectangle where we define two variables, length and the width of rectangle. Length and width of rectangle. These are called the data fields or the fields of the class. Whatever the data we define inside the class, we call it as in fields of that class. Okay, so I'm declaring two variables here. So let me just write a class called rectangle. And this class rectangle has two integer variable, int length and int width. Fine. Now this class has no methods. It has only data fields, which are the length and the width. Okay, fields. These are the fields. That is data fields. You can say, or fields of the class. You can see. Right. Now this has only data. It does not have anything in it. I mean, no functions, no methods. Okay. So this is how we can add if we have like two variables of same time, we can add in this fashion. But preferred is this one. You define every field separate. Okay.
Sir, I have a question.
Yes, please.
So we can, in one program, we can do like class for fields and class for method?
No, whenever we write a class, we define the class, and inside the class, we look into all its methods and all its fields in that class. Okay. We can write another class, we can write 3 class, 10 classes, no problem. But whenever we define a class, we want to define a class for some purpose. Every class is defined for some purpose. For example, rectangle class. Rectangle class is defined to describe a rectangle. A rectangle has length and the width. We can set the length and the width of the rectangle. We can get the area of rectangle. Whatever the functions you have related to the rectangle, we can do that. Okay, that we need to define completely in that class so that we can use that class completely. Okay, if you are just leaving with this fields, a class rectangle, that's fine, no problem. And there is no syntax error here. But at the end, what is the use of this class? How you are going to use this class? You might need some inheritance, or you might need some other method to take these values and to calculate the area and so on about the rectangle. But still now I can say that this class is okay. There is no problem in it. Declaring a class like this with only the fields, no problem. Compilation, there is no compilation problem, nothing. This class still works fine. Okay. And what does it have? It has only two variables. Fine. But we need to add something here, that is the methods that is used in this rectangle class, that is used by the objects of the rectangle class. Those are called the methods, right? So we need to use it, we need to define them. Okay, so now we are defining the methods. Okay, we are just defining the methods. We are not going to we are defining the data fields, not methods, the data fields. Okay, the next step is to define the methods or add the methods to the class. Okay, because every class has some operations to do. Like the rectangle class has an operations like find the area of the rectangle, set the length, set the width of the rectangle. Okay, get the length, get the width of the rectangle. Like you want to print the length, what is the length of the rectangle? You want to print what is the width of the rectangle. You want to print what is the area of the rectangle. So for these all we need methods, right? We need methods. So that we need to add the methods to the class. Is it clear, student who asked this question?
Yes, clear.
I'm going to add here some methods to this class. Let's say that I'll add a method called public void set length int l. Now this method will set the length to whatever we pass to this method. Similarly, I can set the public void set width, let's say int w as a parameter. So I'll say width is equal to w. This is okay. Now these two methods here, one method to set the length, one method to set the width. Now what if someone want to say like, no, I want to use only one method, that method both set the width and the length. You can do that also. Let's say for example, I'll write public void set data int length and int width, two parameters, one for length, okay, sorry, L it is, and one for width. Fine. Now this works fine, and this method set data is setting both length and the width, whereas set width will set only the width and set length will only set the length. Now these set methods are why I define these set methods. In my mind, what I want to do as a programmer is that I want to give the methods in such a way that if I want to change the length of the rectangle, if I want to change the width of the rectangle, or if I want to change both, okay, I can call these methods and give the new length, give the new width, and give the new length and width both together to change the length, width, and all. Okay. Similarly, if I want to get the length and the width, I can write the get methods public int get length. It does not take any argument because we are just returning the length here. So this will return me the length of the rectangle. Similarly, I can say public int get width, and this will return me the width of the rectangle. Fine. So what does it does for me? Whenever I want to print I want to check, or I want to take what is the width or what is the length of the rectangle, I can simply take from the calling these methods. Okay. Now I want to add more method. As a programmer, I want to do more in the class, in this class, that I want to add more methods. For example, I want to add a method to calculate the area of rectangle. Okay, so I'll declare a method public. It returns a value, that is the area, as an integer. For example, I'll say get area, right? It takes no arguments and it will return me the area of rectangle. Now what is the area of rectangle? It is the length multiplied by width. It is the area. So it will return me length multiplied by width, that is the area of rectangle. Fine. So I see here my complete class rectangle. It has two fields which are length and the width of a rectangle. It has few methods: set length, set width, set data, or get length, get width, and get area method. Similarly, whatever the methods you want to add, you can add here. Okay, whatever you feel the methods I want to add in my class, you can add those methods. Okay, now this class represent an object called rectangle. This class represent a rectangle, and we can create objects of rectangle from this class with different sizes. For example, I can create a rectangle of 2 length, 4 width. I can create a rectangle of 4 width and 6 length. It's up to me, whatever the sizes I want, I can create a rectangle, and I can represent a rectangle in this class. Now if I create this class and you want to use this class, and I want to give this class to someone as an executable program, and I'll say that, listen, this is a rectangle class. You can create any number of rectangle objects of it by passing length and the width, and you can change the length and the width. You can get the area of rectangle from this class. What is the names of the methods? Get area is the name of a method that it will get you the area. If you want length, get length. If you want width, get width, and so on. So I need to provide some documentation that, okay, this is my class and this class will do XYZ with some documentation. Now my class is ready here. Fine. So this is how you add the fields and the methods in the class. Okay. So the type of the method name and the parameter list. Okay. So for example, void get data, or this is set data, not get data, or you can say set data or get data, whatever. Fine. So why we use void here? Because it does not return any value. We have seen that in the methods, right? When we use void and when we use any return data type. Okay. So this is another method adding here, which is rect area, or calculating the area of a rectangle. It calculates the area and return the area. Okay. Fine. Okay, member access modifiers of the class. We have seen the access modifiers in our previous session. We have private, public, and protected. We also have another one called internal. Okay, we know that any member of a class is private, is accessible only in that class, and is not accessible outside the class. Okay, and any member is public, is accessible anywhere, from anywhere, inside the class, outside the class. And protected members are accessible only in that class where we declare this member and its successor classes, like its subclasses, also called the derived classes in inheritance. Okay, now what I mean here, member means the fields and the methods. Member here means the field and the method. For example, what are the members of rectangle class? Length, width. set length, set width, set data, get length, get width, get area. These are all members of the class rectangle. So we set some, for example, here I set this set length as public. It means I can access set length by passing one parameter of type integer from anywhere. It is public. Here it is public, public, public. That means all these methods I can access from outside the class. Right? Here I did not specify anything. By default, it is internal. I can access inside this program, right? In this complete namespace program, I can access this. In this namespace session 2, I can access these fields. Okay, here I can define it as public also, no problem. If I want to define it like public, that it can be accessible somewhere, or I don't want anyone to access this data directly. I'll just make it as private. Why? Data is very important, right? Everywhere data is important thing. Fine. So I'll make the data private. No one can access this data directly, but can access by using this methods called get length, get width, because they are public. They take the width and length and they'll return the length. But directly you cannot update this data because it is private and it is accessible only in this rectangle class and not outside the rectangle class. Okay, so those are access specifier. You have seen these access specifier in the last session also. Fine. Now after defining the classes, the next thing is creating objects of the classes. So objects are nothing but the real world entity of which has some data, and does some functions. Okay, we call this that as an object. Fine. So now here we can create an objects of the classes what we define. How we create an object? We create it like it's more very much similar like how you create the variables. Fine. So what we have to do is name of the class, name of the object. This is just a declaration. And to instantiate, the name of the object is equal to new the rectangle. This is called constructor. Okay, new is an operator that assigns memory to this object, which is required to store the fields, which is, for example, for rectangle class, length and the width. Okay. Now these two can be combined to write in one line. That is how, for example, this rectangle class in my main method, I want to create objects of rectangle. So I'll say rectangle R1 is equal to new rectangle. Now R1 is an object which is a rectangle object. R1 has some data, right? What is the data of R1? Length and the width. That is the data of R1. But R1 cannot directly access length and the width. R1 dot length, you don't have this. Why? Why it is not accessible? R1 dot length. Can someone answer me?
Because
Students.
we change it to private.
Yes, very good. Because it is private, we cannot access private because we said that private is accessible only inside this class. We closed the class here. The rectangle class is closed here. So it is accessible only inside the class and not outside the class. That means I cannot directly access this. But I can access the public methods to set the rectangle length and the width. So R1 dot set data. If I want to set both length and the width 2, 4, this will set both length and the width. Okay. Yes, it is private. Fine, thank you. Okay. If I want to set the data one by one, I want to set the length and the width separately, I have those methods. Set length, I have length is 2, for example, and r1 dot set width I have, which is 4. Both the way it is okay. Okay. Now let me just allow me to just I have created one object r1 and I set the data of r1 as 2, 4. The length is 2, width is 4. I can create any number of objects. I'll create another rectangle r2 with new rectangle, and I can set, for example, I'll use set length and set width here for r2. 3 r1 dot set width of 4, 3, 4. So how many objects I have created here? 2 objects. One is r1, the other is r2. r1 is in rectangle with length 2, width 4, and r2 is in rectangle with length 3, width 4. Similarly, I can create hundreds, thousands and thousands of objects of rectangle class. So just take an example of a student class. If once we write a student class, one class, where we define all the properties or the fields of a student and all the required methods of the student in that class, that is done for us to create thousands and thousands of student objects and set their data. Set the student name, set the student email, set the student phone number, and everything. Okay, so this in this case I am just creating 2 objects with setting their length and width. I am using these methods: set length, set width, set data. Okay, now if I want to print the rectangle data, for example, I'll say console.writeLine the r1, or say the rectangle 1 data is, so let me just say console.writeLine length, width, width is 1, and area is 2. Now I'll call here for r1 dot, I want what length. I'll say get length, get me the length of r1, comma r1 dot get width, comma r1 dot get area. So I'm printing the length, width, and the area of the rectangle 1. Okay, so what is the length? I have set 2 and 4, and the area is 2 by 4, it is 8. Okay, Bismillah. So what we get here, rectangle 1 data is, what is the length? That is 3, width 4, area 12. Is it 3, 4? We change it to 3, 4. Yeah, why? Because here we set that r1 set 3, r1 dot set 4. See? And mashallah, you are sleeping with me. Anyway, I change it to the R2 so that it is a rectangle 2 data. Now let us look into the rectangle 1 data, that is 2 and 4. Here is it. So we see rectangle 1 data, length 2, width 4, area is 8. Okay. Similarly, we can write for rectangle 2. Now, what if, for example, I want to change rectangle 1, let's say the length, okay, before printing this data, I can simply call R1 dot set length to, let's say, 4. So length is 4, width is previous width, which is 4. Okay, length is 4, or let me change length to 5 instead of 4. Okay, and width is 4 because by using set length. So we should get different here. Length is 5, width is 4, area is 20. This way we can change the length and the width. That means we can change the object data by calling these set and get methods, by calling these set methods, and we can get the object data by calling these get methods. Okay, so I'm just simply calling this here. Similarly, I can do the same for rectangle 2, right? For rectangle 2, I can get R2 here, R2 dot get length, then R2 dot get width, then R2 dot get area. So I can say rectangle 2 data is length 3, width 4, area is 12. Clear? Is there any doubt, any questions? Things are clear? How about other students? Great. Fine. So let's move to the next topic here. This is accessing the classes. That's fine. Okay, no problem. We use to access any class member, that is the fields, as well as the members of the class, the fields and the methods. We use the object name dot the name of the field. If the variables are public, you can access it. If not public, whatever the public properties, okay, or protected properties, you can access them. Okay, for a method, object dot method name with the parameters, if there is any parameters. If no parameters, we don't pass any parameters. For an instance, for example, we see here, when we call set length, we pass one parameter, because set length takes one parameter here. Set width take one parameter, set data take two parameters. So when we call set data, we pass two parameters. One set width, one parameter, set length. But some methods does not take any parameters or any arguments. So we have get length, get width, get area, does not take any arguments, right, or any parameters. So we call them without any passing any parameters. Okay, but at the end, how we call them? We create an object and we use dot, r1 dot the name of the method and its parameters. Okay. This is rectangle area, and you are all clear with this. Now let's move to the constructors. What are the constructors and why we need the constructors? Constructors are used to create objects. Their name suggests that they are to create or construct the objects. Constructors. Okay. Whenever we declare or whenever we create an object, for example, we use constructors. See, this is a default constructor, rectangle. Okay, it is more or less like a method with the brackets. You see, any method will have these brackets, right? more or less, yeah, it is similar like method, but it has the same name as the class name. Rectangle, class name rectangle, its constructor name is rectangle. Default constructor, it means it does not take any parameters here. And these are used to create the objects. Without these constructors, you cannot create the objects. Fine. So constructors are used to create the objects. Now, we did not write any constructor here. Okay, but from there where this constructor is coming, this is by default. Okay, but if you want to write your constructor, if you want to write your own constructor. Now, but before that, let me show you one more thing here. For example, I am creating another rectangle object. Rectangle R3 is equal to new rectangle by using the default constructor. Now, what is R3 length and what is R3 width? Can someone help me in this? What is R3, the rectangle 3, R3 length and the width? Yes, please.
Doctor, we can put anything we want, right?
No, I'm not putting anything. Now, at this point, after I declare it, at this point, if I print length and the width of the rectangle, what it will be? Please use your mic, please. The student who is typing, use your mic, please.
It will be undefined.
Undefined. Okay. Any other answer? Okay. Very simple. It will be by default, it will take a default value. Okay. Now, what is the default value for integer? What is the default value for integer?
0.
Yes. So you see here rectangle length 0, width 0, area 0. So whenever we create a by default, by using default constructor, we create an object. Default values for their properties or for their fields are assigned. Integer 0, double 0.0, string null character. Okay, default values are using. Now, when I want to set the values for R3, I call the method whether set data or I call set length, set width, like I did for R1 and R2. Okay, I'm using that to set the data of the. Now, using constructors, when we create an object, right, we have an option to give its values, the data field values from the constructor itself, so that when the object is created, their values are assigned to their fields. How it is? We need to write a constructor, right? After the fields, I'll define here constructors. One is default constructor, right? That is by default. We can write our own constructor. Constructors should always be public because they are used to create the objects outside the class. So it should always be public. Does not have any return type, not even void, because constructor does not return any value. So we directly write the name of the class. Okay. This is a default constructor, which is by default is available. But if you want to write default constructor, you can write. And you want to set the default value for the rectangle length and the width. For example, whenever I create a rectangle, if I am not giving any values, then my rectangle should be 1 by 1, not 0 by 0. By default, my rectangle will be 1 by 1. Then you can set the default values here. Length is equal to 1 and width is equal to 1. Now you see what is the default value for rectangle 3. It is 1 and 1. You can see length 1, width 1, area is 1. This is my default values. What I am doing is I am overriding this default constructor which is provided by the C# for this class. I am overwriting it. I am changing its definition to set the default values to be 1 and 1. Clear? Any doubts? Anything?
No, Dr. Clear.
Okay. What if I want a rectangle for which I define the length and the width at the time of creating the rectangle object? It is very simple. Just pass two arguments to the rectangle. Length is equal to L and width is equal to W. So whenever I create a rectangle, just with the constructor pass these two values that will be set for length and the width. So let me create a rectangle R3 now with the values of, let's say, 1, 4. So what does it happens now? Now this rectangle, when I create R3 object, rectangle constructor with parameters is here. This will be invoked, 1 for the length, 4 for width, which will be set the length and the width of the rectangle R3. And now you can see the length and the width of rectangle R3 as 1 and 4. Length 1, width 4, area is 4. Okay, so I am passing the length and the width at the time of creating object. In this case, I don't need to set data, I don't need set length, set width. I am directly passing the length and the width of the rectangle at the time of creating the rectangle. Okay, this is possible by using constructors. So I write a constructor here with parameters to set the length and the width of the rectangle. Okay. So these are the constructors. These are called the constructors. So constructors basically are used to create the objects. By default, there is a default constructor which is used here to create an object that set the default value of the object fields. For example, here length and the width. Later we can set the data by calling the methods called like set data or set length and set width, any set method to set the value. Or we can have an argument constructor where I can pass the argument as the data field values for particular object that I create by using the argument constructors. Right. So this is the job of the constructors, and constructors are very good feature in OOMS that whenever we create an object, we just pass its values and we get that object ready with its values. You don't need to call set methods and all. Later you can change the values. For example, here I'm just use 1 and 4, right? Later and after some time, let's say, okay, I want to update the R3 length. So I'll say R3 dot set length of 3. Now the length of R3 becomes length of the rectangle 3 is 3 now. Okay, at the time of creation it is 4, but I changed later to 3. So now it will be 3. Okay, by using this set. You can see now here it is 3, length is 3 for rectangle 3 and width is 4 and the area is 12. Okay, so these are called the constructors and it's very powerful, and we can have the constructors in our classes. Okay, so it is constructor method is written here. Okay, it is always public, does not have any return type here, not even byte. It has same name as the class name. Okay, it can be default, it can take parameters. We also have something called destructor. Destructor is just opposite to constructor. Constructor is used to create object, where destructor is used to destroy the object. because object takes memory in the system, right? Whenever we create an object and we initialize an object with new by using new operator, it takes memory to store its data, right? These rectangle object, for example, I am creating this rectangle class, and I am creating the rectangle object here R1, R2, and R3. Okay, fine. So R1, whenever I create an object here, I initialize it here with new operator. The memory is given in the system for R1 data. Now, what is R1 data? What is the data? R1 data?
Set the data.
length 2 width 4.
Yeah, it has two data fields, length and the width, okay, of type integer. So integer takes 4 bytes of memory, 4 bytes, 8 bytes are preserved here for R1 in the system. So whenever we create an object, we create it by using constructors. When the constructors are used, the data is set for the object. When the data is set for the object, the space is occupied in the system, right? When these objects are no more in use, we can destroy these objects and release the memory, right? Some of like in Java, there is something called garbage collector in Java that release all the memory of the unused objects. Okay, so here explicitly we can kill the object, we can destroy the object by using something called destructor. Okay, now what is a destructor? As I said, it is just opposite to constructor. It means it is to destroy the objects. Okay, so the name of the destructor is same as the class name, preceded with a tilde operator. Say with a tilde operator that you can find on the keyboard on the top left, right below the escape key. Right. So these are used to just to release the memory if the objects are holding these memories. So here, for example, if line is a class, this is a destructor of the line with a tilde operator, and just that's it. If you want to define something, if the constructor is an object is deleted or something like that, you can define, or you can keep this empty. It simply kill the objects or release the memory which is associated with the objects. Okay. Fine. So this is all what we have for you in this chapter, which is classes and objects. So the overall, we got an idea about how to write a classes, what to include inside the classes, the data fields and methods. Excuse me. Okay, the data fields inside the classes, how we add the data fields, okay, with different access specifiers, whether we can keep them public or private or protected. It depends on the scenario, depends on how you want to keep the data safe. Then we have the methods, right, to operate on the data, that we want to change the data, we want to access the data, we write the methods. Okay, these data and the methods, whatever we have inside this class, we call them as a members of the class. And then we have seen the constructors and the destructors in a class, how we write the constructors and the destructors of the class. So this is all what we have here in this chapter number 7, which is about classes and objects. Fine. So you got clear idea about classes and objects. Do you have any question? Any questions?
No, all clear. Thank you.
That's great. Fine.